A pleasant good morning to all. We welcome you to the third day of 5 days faculty development program sponsored by AICTE Training and Learning Academy on Novel Materials for Next Generations. I am extremely honored and privileged to introduce Dr. S. Jayabal sir, postdoctoral researcher, School of Mathematics and Physics, University of Science and Technology, Beijing, China. He graduated with BSc Chemistry from Bardiyar University, Coimbatore, and completed his post-graduation MPhil and PhD in Chemistry from Madurai Kamaraj University. He awarded as a UGC JRF Meritorious Fellow by University Grand Commission under Basic Scientific Research Scheme, New Delhi in 2012. Dr. S. Jaibal served as Research Assistant at Low Dimensional Material Research Center, Department of Physics, Faculty of Science, University of Malaya, Malaysia from 2014 to 2016. Sir awarded as a Chinese Academy of Sciences President's International Fellowship Initiative for postdoctoral researchers in 2019 and also awarded for postdoctoral international exchange program by Office of China Postdoctoral Council, Government of China in 2019. He worked as a postdoctoral researcher for School of Mathematics and Physics, University of Science and Technology, Beijing, China from 2017 to 2020. He acting as a potential reviewer for Journal of Alloys and Compounds, Atmospheric Environment, Materials Today Proceedings, IEEE Photonics Technology Letters, International Journal of Nanomedicine and Journal of Testing and Evaluation. Dr. S. Jaibal sir, research interests are mono-bimetallic nanostructured materials, two-dimensional materials, optical sensors, electrochemical sensors, electrocatalysis, electrolysis, and fuel cells. Sir organized and participated in an impressive number of conferences and workshops. Dr. S. Jaibal has published more than 19 articles in reputed scientific journals, mostly either the first or corresponding author, and published a book chapter in the Royal Society of Chemistry. I am happily inviting Dr. S. Jaibal sir for the technical session 1 entitled on Insight into the Correlation of the Metal Support Interactions with Electrocatalytic Activity and Durability. Now the session is over to you, sir.
Hello.
Yes, sir.
Uh, So my slide is visible to everyone.
Sir, visible, sir. Sir, please give slideshow.
Yeah.
Yes, sir. Visible, sir.
Okay. So good morning to everyone. First of all, I would like to thank the organizing committee, postgraduate department of chemistry, NGM College, Polachi, for arranging such a nice event, and my sincere thanks to Dr. K. Poonkudi for inviting me this lecture. So we are moving to the topic entitled insight into the correlation of metal support interactions with electrocatalytic activity and durability. So,
Excuse me, sir.
Yes, yes.
Some noises are there. There is some disturbances during your speak. Hello.
Yes, yes.
Okay, sir.
Now
Now,
is
now okay.
okay. Okay, so this is a outline of our today's lecture, starting with some introduction, deals about some metal support interactions, and we are particularly deals with some metal support interface, which includes the role of platinum metal and the role of supports in platinum support materials. And we particularly discuss about metal support interactions, which also includes electronic and geometric effects. So further, we move to some advanced strategies of tailoring metal support interactions, and then we further move to some characterization of metal support interactions, including some conventional and some advanced characterizations. And finally, we have some summary and outlooks for then future outlooks. Let's start with some introduction about some platinum supported materials. Usually, the carbon supported platinum is used as an electrocatalyst for both hydrogen oxidation reaction at the anode and oxygen reduction reactions, ORR. We simply call ORR at the cathode, especially for fuel cell applications. For fuel cell applications, the activity and durability of the platinum carbon largely depends on the type of the carbon support where we are used in our catalytic studies, and their structure related properties of the metal and carbon support. So we have some drawbacks in this the platinum carbon catalyst due to the limited durability for our electrocatalyst. This is due to the degradation of.
Excuse me, sir.
Yes.
You are using mic or without mic?
Yeah, mic. I am using mic.
You can adjust the mic, sir. There is a air sound, I think.
Okay. It's okay now?
Yes, sir. You can speak now.
Okay. So the limited durability of the platinum carbon catalyst is mainly due to some degradation of the catalyst, and which significantly reduces our applications and life of the fuel cell reactions. So which remains the issue need to resolve for the future. So we are particularly focused on the activity and durability of the platinum support, especially for platinum support materials. And some key issue need to be resolved. We will discuss. The platinum carbon catalyst have some good stability, which can be improved by changing the carbon structure and tuning the metal support interactions. So usually people using platinum carbon catalyst by changing their carbon structures and thereby the tuning the metal support interactions. So the nature of the metal support interactions in the platinum carbon catalyst. Okay. The nature of the metal support interactions in the platinum carbon catalyst, which interfere the effects between the platinum and carbon support. So again, it greatly affect the surface property of the electrocatalyst. So from this, the surface property of the electrocatalyst is mainly due to the interface effects between the platinum and carbon support. So from which we clearly understanding the role of metal support interactions in the activity and durability is due to the interface effects for the fuel cell catalysis. So this is a schematic representation of metal support interaction in the electrocatalysis. So this is the carbon support. We use some graphene based material for the representation. This is our metal nanoparticles, for example platinum.
Excuse me, sir.
Yes.
Sir, again some air sound or microphone nearby you is causing noise. An interruption continuously coming with your noise, sir. Can you please check whether any microphone is near with you, or you can adjust your mic so that air sound won't come, or kindly use headset like that.
Okay.
Or without headset.
Okay. Wait.
Thank you.
Hello.
Yes, sir.
So now is clearly visible my voice.
Yes, sir. The voice is audible and there is no interruption, sir. Thank you, sir.
Okay.
You can continue, sir. Thank you.
Okay. So this is the schematic representation of metal support interactions in the electrocatalyst. So this is a schematic model of some metal with some carbon support interaction. So this is the metal support interactions from which the interface is started from here. So usually nowadays people are using for especially for nano particle with some multi-metallic alloys, modification with some multi-metallic alloys, and also nowadays some people are moving towards some doping and modification of platinum nanoparticles to improve the metal support interactions. So further from the improved metal support interactions, is strongly depend on the activity and the durability. So before going to start, we have to know some basic about the electrocatalytic processes. So let's start with some electrocatalytic energy storage and conversion. So we all know the electrocatalytic process plays an important role in energy storage and conversion that achieve between the mutual transformation between electrical and chemical energies. So for example, we start with some water. It can be converted to higher oxygen and also for some hydrogen. So which is called energy storage reactions. And again, where the oxygen can be converted into water for through some energy conversions by hydrogen oxidation reaction and oxygen reduction reaction. So we particularly focus on this for fuel cell applications. So from the electrocatalysis, the researchers have confirmed is the energy storage and conversion process is green and we can use for our everyday life as some fuels and for some hydrogen storage and some for applications. So this is the current potential curve for our the oxidation and hydrogen oxidation and oxygen reduction reactions. Let's start with some potential. Usually hydrogen oxygen reactions start with some 0, and overall starts with 1.23 electron volt. So next we will move to some starting with some metal support interface. So from before going to metal support interface, we have to know some the role of supports in platinum carbon material. So platinum, we all know the platinum is one of the most most usable electrocatalyst for our choice due to its high electrocatalytic activity, but it has some limitations, especially some high cost and limited reserve of platinum. So, and also increasing the platinum loading on the carbon support, which leads to the agglomeration of platinum nanoparticles, and thus decrease in the surface area of the support materials. So, which again limits the catalytic performance of our fuel cell. And also the catalyst support have also have impact on the dispersion of platinum nanoparticles, which also play important role in the catalytic activity and durability. So depending upon the size of the platinum nanoparticles, it can change the catalytic activity and durability. And the strong interaction between the platinum and its support not only enhances the catalytic activity, but also decreases catalytic degradation. So if in the metal support interaction, we also have some going to focus on some degradation mechanisms. So if we have some support materials, why we need some support materials is for achieving some highly durable and efficient catalyst. So support materials must be some high specific surface area for the effective absorption of platinum nanoparticles, and it has possess some high electrochemical stability under operating conditions, and it must be a high electronic conductivity, and it should be easily recovered from the platinum catalyst. So usually the supports are classified into two types. One is the primary, and another one is the secondary supports. Usually the carbon-based materials like carbon black, carbon nanotubes, and graphene used as support materials. And secondary supports are some oxide-based materials. For example, TiO2, CeO2, and tin oxides. So first, now early people are using carbon black as a support materials, and it also has some limitations and drawbacks. And nowadays, people are moving towards carbon nanotube and graphene, especially for the secondary supports like TiO2, cerium oxide, and tin oxides. For some research are using for some strong metal support interactions, especially for strong metal support interactions. So metal support interactions, the effects of metal support interaction on the catalytic activity and durability will especially depends upon the two effects. So one is electronic effects, and the other one is the geometric effects. So electronic effects which arises from the energy difference between the metal and its support material. So resulting in the electron charge transfer from metal to support, or from the support to metal, in order to attain equilibrium at the interfaces. And the other effects is geometric effects, which arises due to the heterogeneity of lattice mismatch between the metal particles and the support, which makes a change in the morphology of the metal nanoparticles, and resulted the exposed crystallographic facelets and coordination number of the metal atoms at the surface of the metal nanoparticles, which influences their catalytic activities. So we all know the catalytic activities is depends on the crystallographic phases and coordination number at the of the metal atoms at the surface. So we first discuss about some effects on electronic effects. So how it generate means the generation of metal support interaction will change the electronic structure of the catalyst. So depending upon the metal support interaction, the electronic structure of the catalyst will change. So we can easily tune the metal support interactions, and also a structural change in the metal catalyst directly alters the catalytic property of the supported metal catalyst. So this is a schematic view of metal and support interactions. So depending upon the interaction of metal with support, the electron transfer takes place from metal to support or from support to metal. So depending upon the electron densities present in the metal or in support materials. So we represent in this figure. So the change in the electronic structure of the supported metal catalyst can also alter the binding energy of the adsorbents, also which we are interested for electrocatalyst reactions, or the charge distribution in the catalyst. So after altering the binding energy of the adsorbents or the electron or the charge distribution in the catalyst, we can tuning the metal support interactions. So this is a schematic view of interaction of platinum nanoparticles with spark band support, which leads to electronic transfer between them. So from this, we can clearly understand the electron transfer from metal or metal to support or support to metal. So this is energy level diagrams at the metal support interactions. So the EV means the vacuum energy, EF means the Fermi energy. This is metal, and this is support an energy level for the support materials. So we after interaction with metal and support material, depending upon the Fermi energy level, the electron can transfer from support to metal or from metal to support is schematically represented in this figure. So this clearly reveals the electron transfer or charge transfer from metal to support or from support to metal can easily influences our catalytic activity and durability of our electrocatalytic reactions. So this scheme we published in this journal. So next, the another effect is geometric effects. Let's start with the geometric change. It means morphology or size in the metal nanoparticles, which reveals the nature of the support metal support interactions. This is a schematic view of the metal support interactions. So after metal interaction with the support, the metal can be changed by morphology or size. So depending upon the changing in the morphology and the size, it can alter the activity and durability of the electrocatalytic systems. So one of the important information, the formation of various morphologies in the support material can result in the decrease of unsaturated metal atoms at the surface and higher stability towards electrocatalytic reactions. So next, the intimate connection between the activity of platinum carbon material and metal support interactions. So the strong interaction, the strong interfacial interaction between the platinum and its support is able to alter the level of platinum d-band states and in turn influence the adsorption and desorption of the intermediates on the surface of the platinum nanoparticle, and which influences the electrocatalytic activity. So from the interaction between the platinum and support, so one of the main point is the energy level of platinum d-bands is able to alter. So from this idea, we can improve our electrocatalytic activity for fuel cell applications. And the other one is the binding energy of the reactant molecule to platinum nanoparticle is decreases the electron density on the platinum decreases due to the electron transfer from the platinum to the support, and which facilitates better electrocatalytic activity. So the binding energy of the reactant molecule to the platinum nanoparticle is a key thing for the better electrocatalytic activity due to this electron density on the platinum nanoparticle surface. Then the other point is the electrocatalytic activity strongly depends on the interfacial electron transfer from the platinum nanoparticle to the support, which influences the electronic interactions between the catalytic surface and reaction intermediates, and which varies with the structures and morphology of the platinum and carbon support. So from this point, from the platinum nanoparticle structures and their morphologies, the platinum carbon support catalytic activity alters. So this is a intimate connection between the degradation of the platinum carbon material and the metal support interactions. So this is another topic in the metal support interactions is a main point is degradation of carbon supported platinum nanoparticle catalysts, which includes two primary process. One is the carbon corrosion, another one is the platinum dissolution. So this is a schematic view of the degradation process. This is the carbon corrosion, and this is the platinum dissolution. So why the carbon corrosion and the platinum dissolution takes place? But means while doing our electrocatalytic reactions in open circuit voltage and increasing potentials towards some more energy, which causes the corrosion of carbon, and which simultaneously causes platinum dissolution of platinum particles on the support. So from the carbon corrosion and platinum dissolution, another secondary process is also there, is particle detachment and agglomeration and Ostwald returning. So after carbon corrosion takes place and platinum dissolution takes place, usually the platinum nanoparticle is detached from the carbon support, and also another one is agglomeration of platinum nanoparticles, and the other one is Ostwald refining, so which also arises due to the carbon corrosion. So weak interaction after carbon corrosion, the weak interaction between metal and support leads to the movement of platinum particles towards the nearer particle, which increases the size of the platinum nanoparticle. So the platinum atoms moves towards the nearby platinum particle by the carbon support is usually we say as 2D, and by another means of by using electrolyte ions we say as 3D Ostwald refining. And what happens means after carbon corrosion and the platinum dissolution will decrease the electrical conductivity at the metal support interfaces, and thereby decrease the electronic contact with the current collector. Current collector here means our electrode. Then the durability of the electrocatalyst is strongly dependent on the properties of both nanoparticles and carbon support materials and the specific interaction between. So from this degradation process, we finally assumes our durability of the electrocatalyst is strongly dependent on the property of the metal nanoparticles and the property and the surface property of the carbon material. So how to improve the to improve our the degradation of the carbon support materials for our reactions. Let's we start with some strategies of tailoring platinum support interactions for improving our electrocatalytic reactions. So first one is the doping or functionalization engineering. So doping with some heteroatoms, for example, nitrogen, boron, phosphorus, or sulfur. People nowadays using nitrogen as one of the most suitable heteroatoms for carbon support. On the surface of the carbon support has been proven as an effective way to alter the chemical and electrical properties of the carbon supports. While incorporating the heteroatoms in the carbon support causes some defects in their carbon support. So it alters the surface geometrical structure via the electron redistribution and the intermediate absorption energies. So which also acts as the so formed the defects and the redistribution of absorption energies, which also acts as a new active sites and strong interactive sites for platinum nanoparticles. And then the presence of oxygenated functional groups on the carbon support can modify the surface electron density of the carbon material, so which also affect or alter the interaction between the platinum nanoparticles and support. So people nowadays using some oxygenated functional groups for the carbon support, something like O2 something, O2 like groups, and which affect the interaction between the platinum particles and the support. So another important topic in this is the carbon support combined or replaced or with metal oxide supports. So the another one important material is the metal oxide, which are attractive materials for electrocatalytic supports in the fuel cell cathodes due to their chemical and electrochemical stability against carbon corrosion. So most of the people nowadays are using metal oxides. So these metal oxide also have some limitations, which limits the electronic conductivity due to their semiconductor behavior. So which can be further avoided by the formation of some composite or mixed materials with some carbon or allo-valent ions, so that may be replaced or combined with some carbon support materials. This is a schematic view of strong metal support interactions. So this is a metal nanoparticle strongly interacted with the metal oxide support. Here we are using TaO2 as a metal oxide support. So from this figure, it's clearly understand the platinum particles and the TaO2 particle is strongly interact with their surface. So the activity increases with decreasing particle size, whereas the durability increases when the nanoparticle size increases to a certain level. So this means our electrocatalytic activity is increases with the decreasing the metal nanoparticle. When the size of this particle is decreases, our catalytic activity keep on increasing, and durability is also increases, but it is limited to some certain level. And also the enhancement in the activity and durability of the supported platinum catalyst is attributed to the alterations of electronic and geometric effects caused by the metals. So from this doping and modification engineering or carbon replaced with some metal oxides, proven the enhancement in the catalytic activity and durability of the metal support catalyst. So next we move on to how to characterize the metal support interactions. So nowadays people are using some conventional characterization methods and also some advanced characterization tools also nowadays we are using. So we start from the basic characterization method with XORD. So this XORD analysis which confirms the state and dimension of the platinum particles on the carbon support, so which can be an effective technique for understanding the interactions between the metal and carbon support. So from that XRD we can understand some interactions between the metal and carbon support. So another one most important technique is nowadays people are using is X-ray photoelectron spectroscopy. So this is also an important technique for identifying the metal composition, usually at surface, and the oxidation state of the metal and the electronic nature of the metal and carbon materials. So from the XPS analysis, the shift in the binding energy is a clear indication of the electronic structure change resulting from the metal support interaction. So upon measuring the binding energy of the metal peak, for example, here we are using some platinum. So the platinum peak, so we can easily understand the electronic structure, nature of the electronic structures. So from that we can conclude some how the metal support interactions affect electrocatalytic activity and durability. So usually for example for platinum, yes, yes, if in platinum 4 to higher energy was observed and attributed to the alteration in the electronic structure or the coordination environment that leads to a partial electron transfer from nitrogen doped carbon support to the metal, and the stabilization of electron rich platinums at the surface. So from this the electron transfer and the electronic structure and the coordination environment, we can easily analyze the metal support interactions at the catalytic reactions. So another one most important technique we are using is X-ray absorption spectroscopy. So which is also important technique for determining the local geometric structure and electronic structure of the materials. So from the X-ray analysis, the individual environment of atoms and the interactions between the intermolecules, for example, binding distance, binding geometry, and the coordination number is also investigated through this technique. So usually this technique is classified into two important types. One is the X-ray absorption near edge structure, or near edge X-ray absorption fine structure, and the extended X-ray absorption fine structure. So we can get in detailed information of the chemical and electronic structure at the platinum carbon interface by using the X-ray absorption near edge structure together with the extended X-ray absorption fine structure. So another important technique is the transmission electron microscopy. Everybody knows about this technique. It's also an important techniques that can reveal the morphological and structural characterization of the metal support interface. One important thing we can characterize at an atomic level, and which this technique involves a model technique to understand the electronic and geometrical effects at the metal support interfaces. So from the 10 images of the our supported platinum nanoparticles provide an evidence about the size and the homogeneous distribution of the particles, platinum particles on the support, usually carbon. So further, the combination of the high resolution TIM analysis with energy dispersive X-ray spectroscopy, usually as EDS, and the electron loss, energy loss spectroscopy can give more information about the geometric relationship between platinum nanoparticles and support. And also from these technique we can examine the presence of defects, heteroatoms, and functional groups on their support. So people nowadays the EDS and EELS used as an effective technique coupled with TIM measurements. So some other methods is also widely used for the characterization of metal support interactions. So one is the electrochemical characterization, such as cyclic voltammetry. This is electrical behavior of the support metals, and then deduce the effect of resulting from the interactions with the support. And finally, all of these techniques we used is so the local environment and the oxidation state or the charge density of the catalyst, so which can be reflect the overall electron density change between the metal support interfaces. So in spite all these techniques have some detailed atomistic information of the metal support interaction and appropriate structure performance relationships of the carbon supported catalyst is not accessible using the above characterization techniques. So all these techniques have we got some important results, but one drawback is we cannot get some atomistic information through these techniques. So we move to some advanced characterization techniques, which includes inelastic neutron scattering spectroscopy. This is very new to for all, which simply we call as INS spectroscopy. So the neutron, why this neutron scattering spectroscopy is important for our characterization is due to this technique is very suitable for investing basic research questions. For example, the hydrogen interactions. So the use of the neutron spectroscopic techniques has some catalytic problems is still quite limited because the neutron beam time is relatively rare and expensive. So the INS spectroscopy is commonly used in catalysis principally due to its sensitivity to the vibration of hydrogen atoms. This technique on the proton dynamics of carbon-based materials have revealed an important details on the surface interface of the support metal catalyst. And also this technique can probe the catalyst in depth rather than the surface deep. Since we studied XPS and TEM are only the surface techniques, but rather this technique is in depth since the neutrons have high penetrating power and it has neutral charge. So another one most important technique for the characterization of metal support interactions is DFT theoretical studies. Is one of the most commonly used techniques by researchers nowadays, usually to determine the electronic interaction between metal and support. The absorption and binding interaction of adsorbates on the surface of the catalyst can be calculated by using these DFT studies, and the supported metal catalyst for DFT calculations discussing the correlation between the metal support interactions and thereby alter the catalytic activity and durability. We have some more information about the catalytic activity and durability of our electrocatalytic reactions. And another one most important things is the density of states of our platinum deep-band energy level. The valence electrons near to the Fermi energy level has some significant influence on the reactant adsorption and disabsorption. So from these two measurements calculations, we can predict the metal support interactions. So this the combination of these theoretical and experimental studies provides some new insights into the metal support interaction. So which guides for the development of some efficient electrocatalyst for high performance. So this is the design principles of our electrocatalyst through metal support interactions. So this is a metal support interaction. So we can designing our material and tuning of our metal support interaction, which includes characterizations by electronic and geometric effect. So there are also some correlation with some DRT analysis. So finally, we design this principle for our this technique. So this is some outlooks of our this study. So the durability of the platinum support metal catalyst is a key problem. So doping heteroatoms in the carbon support is a significant tactic to improve the durability of the metal catalyst, and the doping of nitrogen into the carbon support, which improves both the catalyst dispersion and catalytic activity through experimental characterization and theoretical calculation. So after that, still some advanced characterizations are necessary to clearly understand the role of nitrogen atoms in the metal support interactions. So the study of defect-rich carbon materials is a unique support for metal nanoparticles, so which also important for the electron transfer at the interfaces for high performance catalysts. Then another one important topic is platinum metal oxide support catalyst, which also improve the electrocatalytic activity and durability due to strong metal support interactions. So all the combination of these characterizations, for example, XPS, HRTM, INS, and these theoretical studies, we can clearly understand the interaction between the platinum and the metal oxides and the electron transfer at the interfaces. So further, the development of some in situ characterization methods and real-time observation techniques at the metal support interfaces of the catalyst, which further gives some more information about the electronic effects at the metal support interfaces. So still some great efforts made to be developed new theoretical models for DFT calculations to explore the nature of the interaction between the metal and the support, especially at the atomic and molecular levels. So this is a summary of this topic. We will start with some introduction and the recent advances in the platinum support interactions for better understanding their structure property relationship in the electrocatalysis, and the metal support interaction has proven a vital role in the catalytic activity and the durability of the supported metal catalyst. So the recent developments in XPS, STEM, and INS techniques can be used to reveal the metal support interactions. The most important one, the electronic interaction between the platinum and support, combined with the energy level and theory, gives the promising approach for designing a new novel catalyst with some high activity and durability. So for some more information and some more in-depth study, I recommend to read this paper. So this paper to be published last year in Journal of Material Chemistry A. So from this paper, you can get some more idea about this correlation of the platinum support interactions with their electrocatalytic activity and durability. And next, we move on to some another topic. So from my experience, I cut out these points. So is how to write some tips for writing an effective research paper. So for writing an effective research paper, give some good publications in some high impact journals. So how to write an effective research paper. So this is starting with introduction. First, we conclude with some potential applications of the current problem and how it impact with the social and economic nowadays. So this is one of the most important we have to write in the introduction section. And so what the science or engineering problems is remaining still remaining. This I have to discuss in the introduction section. And so what the previous attempts which failed in our area, this also have to include in the introduction section. And our new plan. This means our idea how to improve our success in this, for example, electrocatalytic reactions. So these 4 points must be very important in the introduction section. If we miss any of this one, the introduction section is not a good one. So nowadays reviewers are expecting introduction should be focused on these 4 points. We have to discuss these 4 points. And we all know the experimental section. So I refer some paper without the instrumentation details and some material details they published. It is not a right way. So we have to include our materials from which company we purchased and all other the purity details we have to given in the experimental section, and what type of instrument used, for example, the brand company details, and we need to given in the experimental details, and also the analysis range. For example, if we do some XPS analysis means, so we have to give the binding energy range and which instrument we are used for that experiment. So these 3 materials, instruments, and analysis is the most important for writing in the experimental one. And next, the results and discussion. So we start writing results and discussion with the key figure first. So let's we have to identify which is the key figure of our results. So we have to give the key figure first, and then supporting figures and tables we have to given, and compare our results with the previous attempts, and also we have to conclude with some qualitative analysis and followed by quantitative analysis. And finally, we have to give some conclusion in the results and discussion with our successful conclusion of our discussions. So missing any of this paragraph or some point is difficult to publish in a very good journal. And also much more important in the supporting figures and tables, we have to give correct number of supporting figures and tables. Usually for a very good research paper, 5 to 7 figures we have to given in the main manuscript. And if we have some more figures means we have to given in the supporting information. Okay. And finally, we have to give some summary of our results, and significance of our results is the most important for our work. So what we this work is useful for in the near future. So we have to explain in the summary. So for more information about this, for writing an effective research paper, I recommend to follow this reference book. The book name, the ACS Style Guide, Effective Communication of Scientific Information. So this book deals with some grammatical informations and how to write with some improved English. So all other things are in this book. So I recommend for writing a good research paper, we need to read this book. So this book has some more information beyond this. Okay. First of all, I would like to thank the Office of China Postdoctoral Council for giving postdoctoral international exchange program, and Science Foundation for funding some research grant to me, and University of Science and Technology Beijing for providing advanced characterization techniques. And I thank Professor Ramaraj, he is my PhD guide from Madurai Kamaraj University, Madurai, and Professor Dongseng Ging, who is my postdoctoral advisor in University of Science and Technology, Beijing. And finally, I would like to thank the organizing committee for organizing such a nice event. Thank you.
Dear participants, kindly share your questions.
Sir, can you able to see the chat box?
Hello.
Sir, can you able to see the chat box?
Wait.
Sir, one question is posted in the chat.
Excuse me.
Yes.
Me a practical application of this in catalyst.
Sir, where? Yes. Any questions? I didn't see any question in the chat.
Have you this
Sir, one question is
applied
palladium
this
also
below
can be used in the same way?
practical?
What is the question? Please once again.
Yes, sir. Is palladium also can be used in the same way instead of platinum? I think.
Yes.
Can we use
We
palladium?
can also use palladium. Also, we can use. Yeah.
Thank you, sir. Another question is, what is Oswald ripening?
Yes. Wait. This Oswald refining is from takes place from the carbon corrosion and platinum dissolution. So this which, in this process, the platinum metals is moved to the nearby platinum particles to form a very large big particle. This process is called Ostwald refining.
Thank you, sir.
Okay.
Dear participants, kindly enable your video for photo session.
Sorry, I cannot enable my video. I don't know why.
No issue, sir.
Okay.
Photo done, ma'am.
So participant, please mute your video and audio. Thank you, sir, for your valuable talk on insight into the role of metal support for the electrocatalytic activity and its durability. I am sure your tips will help young researchers to overcome their difficulties and for designing their research scheme. Thank you, sir.
Okay. Thank you for all.
So thank you for your vibrant interaction and many tips we got, and young researchers definitely use your ideas for their career. Thank you very much, sir.
Okay. Thank you for all.